Welcome to the 10th part of VCAA Math Method 2021 exam paper series. In this video, we still present exam paper 2 section B, question 4, which consists of 8 parts. They relate to normal and binomial distribution questions. Question 4 requires an understanding of the relation between the median value and the dilation factors of the transformed density function. The question requires finding the median value based on the given probability density functions and the dilation factors of the transformed density function based on the given median value.
Hello, Math Champions! I'm Dr. Chen. If you want to improve your math skills and understanding so that you gain confidence, enjoy math more, and get better results, click subscribe and hit the notification button so that you don't miss anything.
Welcome to this VCAA exam paper series. This is section B of 2021 exam 2 paper. There are total 5 extend response questions in section B. In this video, I will present you the 4th extend response question here. In question 4, it states that a teacher coaches their school's table tennis team. The teacher has an adjustable ball machine that they use to help the players practice. The speed, measured in meters per second, of the balls shot by the ball machine is a normally distributed random variable, W. The teacher sets the ball machine with a mean speed of 10 meters per second and a standard deviation of 0.8 meters per second. Part A of this question is to determine the probability when W is greater than or equal to 11. Part B of this question is to find the value of K, which 80% of ball speeds are below the mean speed. Now the teacher adjusts the height setting for the ball machine. The machine now shoots balls high above the table tennis table. Unfortunately, with the new height setting, 8% of balls do not land on the table. Let sample proportion be the random variable representing the sample proportion of balls that do not land on the table in random samples of 25 balls. Based on the adjustment, part C of this question is to find the mean and the standard deviation of sample proportion, while part D of this question is to use the binomial distribution to find the probability when the sample proportion is greater than 0.1. Now the teacher adjusts the spin setting on the ball machine. The spin, measured in revolutions per second, is a continuous random variable x with the probability density function showing on the screen. When x is greater than or equal to 0 but less than 20, f of x equals x over 500. When x is greater than or equal to 20 but less than or equal to 50, f of x equals 50 minus x or over 750. f of x equals 0 when x is elsewhere. Based on the above, part E of this question is to find the maximum possible spin applied by the ball machine. Part F of this question is to find the median spin, and part G of this question is to find the standard deviation of the spin. Now the teacher adjusts the spin setting so that the median spin becomes 30 revolutions per second. This will transform the original probability density function f of x to a new probability density function g of x, where g of x equals a times f of x over b. Based on that, part H of this question is to find the values of a and b for which the new median spin is 30 revolutions per second. Now let's solve this long question by starting from part A. Based on the mean speed of 10 meters per second and a standard deviation of 0.8 meters per second, PR of W is greater than or equal to 11 equals PR of Z is greater than or equal to 11 minus 10 or over 0.8. which equals 0.10565. Part B of this question is to find the value of k such that PR of W is less than k equals 0.8. Based on the normal distribution of random variable W, k is calculated, which equals 10.7. Alternatively, since the probability value 0.8 can be transformed to its corresponding standardized value 0.84162, we have k minus 10 all over 0.8 equals 0.84162. So the value of k can be calculated in this way too. Since part C of this question is to find the mean and the standard deviation of sample proportion, and we know the sample number is 25, sample mean equals 0.08, hence the sample standard deviation equals square root of p times 1 minus p, or in parentheses over n, which equals 0.054259. Part D of this question is to use the binomial distribution to find the distribution of the probability when the sample proportion is greater than 0.1, which equals PR of x is greater than 0.1 times 25, which equals PR of x is greater than 2.5, which equals 1 minus PR of x is less than 3, which equals 0.323. Part E of this question is to find the maximum possible spin based on the given function f of x. Based on the rule of density function f of x as shown in red, we have its primitive function f of x, which equals x squared over 1000 when x is greater than or equal to 0 but less than 20, and f of x equals negative 50 minus x, or in parentheses squared, over 1500 when x is greater than or equal to 20 but less than or equal to 50. Based on the above, the maximum possible spin speed is 50 revolutions per second. Part F of this question is to find the medium spin. According to the definition of the medium and its relevant formula, we have the equation, the integral from negative infinite to x sub m of f of x dx equals 1 over 2, where x sub m is the medium spin. Since the integral from 0 to 20 of x over 500 dx equals x squared over 1000 valued from 0 to 20, which equals 0.4, which is less than 0.5. Hence, the equation to calculate the medium spin is the integral from 20 to x sub m of 50 minus x all over 750 dx equals 0.1. By integrating the left side, we have negative 50 minus x, or in parentheses squared, over 1500 valued from 20 to x sub m equals negative 50 minus x, or in parentheses squared, over 1500 plus 30 squared over 1500 equals 0.1. Solving the equation gives x sub m equals 22.6 revolutions per second. Part G of this question is to find the standard deviation of the spin. Since the expected value e of x equals the integral from 0 to 20 of x times x over 500 dx plus the integral from 20 to 50 of x times 50 minus x, or in parentheses over 750 dx, which equals 70 over 3 after being simplified and calculated. However, the expected value of x squared, e of x squared, equals the integral from 0 to 20 of x squared times x over 500 dx plus the integral from 20 to 50 of x squared times 50 minus x, or in parentheses over 750 dx, which equals 650 after being calculated. Hence, the standard deviation of the spin, SD of x, equals square root of e of x squared minus the square of e of x, which equals square root of 650 minus the square of 70 over 50, which approximately equals 10.3 revolutions per second. Part H of this question is to find the values of a and b, given that g of x equals a times f of x over b, and the median spin becomes 30 revolutions per second. Since g of x equals a times f of x over b, which equals a multiplies x over b, all divided by 500 when x is greater than or equal to 0 but less than 20b, and a times f of x over b equals a multiplies 50 minus x over b, all divided by 750 when x is greater than or equal to 20b but less than or equal to 50b. The integral from negative infinite to infinite of g of x dx equals 1, and g of x equals a times f of x over b. If we let u equals x over b, the integral from negative infinite to infinite of g of x dx equals the integral from 0 to 20b of a multiplies x over b, all divided by 500 dx, plus the integral from 20b to 50b of a multiplies 50 minus x over b, all divided by 750 dx, which is finally simplified to ab, which equals 1. You may see the steps shown on the screen for details. Alternatively, since the area under g of x is 1 over 2 multiplies a times 20b over b, all over 500 times 50b equals ab, which equals 1. Here we continue to work on part H of this question. Since the integral from 0 to 20 over a of a squared x over 500 dx equals 2 over 5, which is less than 0.5. The integral from 20 over a to 30 of a times 50 minus ax, all over 750 dx equals 1 over 10, because the median spin is 30. Solving the equation gives a equals either 10 minus square root of 30 all over 6, or 10 plus square root of 30 all over 6. Accordingly, b equals 3 times 10 plus square root of 30 all in parentheses over 35, or 3 times 10 minus square root of 30 all in parentheses over 35. Due to the median spin is 30 revolutions per second, 50b must be greater than 30. Therefore, we obtain the values a equals 0.75 and b equals 1.33. Here we present you an alternative approach for part H of this question. Since the median spin is 30, 1 over 2 times 50b minus 30, or in parentheses times a times 50 minus 30 over b, or in parentheses over 750 equals 1 over 2, and a times b equals 1. After rearranging and simplifying, we have 3a minus 5, or in parentheses squared, minus 15 over 2 equals 0. Solving this equation gives a either 10 minus square root of 30 all over 6, or 10 plus square root of 30 all over 6. Accordingly, b equals 3 times 10 plus square root of 30 all in parentheses over 35, or 3 times 10 minus square root of 30 all in parentheses over 35. Since 50b must be greater than 30, a equals 0.75 and B equals 1.33. If you enjoyed this video, please give it a thumbs up and subscribe to help me make more math content like this. I will see you in the next video.